the lumber leaves the mill, it's on its way to becoming an essential part of some kind of structure. But one day that structure may face remodeling. When that time comes, an entirely different saw, the Milwaukee Sawzall, will be there. The Sawzall is a reciprocating saw, a power saw with a blade that moves back and forth during cutting. The Sawzall's aim is to live up to its name.
What can't you use a Sawzall for? From cutting birthday cake to lumber to demolition to fire and rescue to... I even knew a guy, he talks about he wanted to get rid of a stump, so he actually used it to cut down in the ground to cut the roots of the stump so he could pull it out.
The Super Sawzall is the top of the Milwaukee line and includes orbital cutting action.
Normally a reciprocating action is straight back and forth. Orbital cutting is more of a circular cut. It's a much more aggressive cut. We have a unique feature to Milwaukee. It's a 360-degree rotating handle. This is nice because it allows the contractor to adjust the handle to the most comfortable position. It generates 0 to 3,000 strokes per minute. So it's literally the fastest reciprocating saw on the market.
The Sawzall has no problem cutting through wood, screws, and nails. Even the steel hinges on this door.
The Sawzall was introduced in 1951 and originally developed for plumbers and electricians. And actually what they were looking for was a compact, durable, lightweight solution to cut basically anything that they ran into.
The original Sawzall was a heavy all-metal tool. Today's version incorporates plastics and nylons for lighter weight and vibration dampening. This Super Sawzall and its blades are made at a Milwaukee electric tool plant, which is not in Milwaukee.
In Greenwood, Mississippi, the heart of the Mississippi Delta, catfish and cotton. The building itself is 150,000 square feet. We make tens of thousands of Sawzalls a year.
The key to making a machine that saws just about anything is manufacturing blades for all types of substrates. Tooth size determines the cutting speed. Smaller teeth cut harder material like metals, but remove less material with each stroke. And a thinner blade means less substrate will actually have to be cut.
The blade we're looking at now is for metal cutting, and the reason we know that because the teeth are finer. There's more TPI, or teeth per inch, because you don't want to have an aggressive bite when you're cutting metal. Comparing it to wood, you can take a heavier cut, a larger chip, because the wood is softer. But on metal, you have to have a finer tooth. As you see on this blade, the tooth is much different from the previous one. It's much larger, the angles are different, the depth of the gullet is different, and this one is designed for a very aggressive sheetrock and plaster cutting.
There are no saws involved in the manufacture of saw blades. The teeth are ground in.
The blade process begins with the uncoiler, with a coil of steel. The uncoiler uncoils it into the straightener. The blade material is straightened prior to going into the press. Once it gets into the press, the blades are stamped out to the configuration of the blade itself. Once they are loaded off of the press, the blades are accumulated into handfuls for the robot. The robot swings over, picks it up, and loads it into the grinder.
A ceramic grinding wheel grinds the saw's tooth pattern into a pack of 90 blades. The grinding wheel forms and sharpens the teeth as a mixture of water and lubricant washes metal filings away. Workers then load the blades into furnaces to temper the metal in order to retain its hardness and its flexibility. Sawzall blades will cut pretty much anything, but these blades make just one tough cut all day long. To saw through stone takes teeth made of the hardest substance of all, and even then, it's a gritty job.